All these are previous IIT questions. We will take one by one. Now you please go through the first question. Take up the first question. You have two satellites P and Q moving in different circular orbits around the Earth, whose radius is capital R. The height of P and Q from the Earth's surface are given, HP and HQ respectively, where HP is R by 3 and HQ is what I need to find. Good. Now the question is, they have given some data for you. What is that data? The ratios of these terms they have given. The ratios of these terms they have given. Now you need to find, what you need to find? Right. Now please go through the question carefully, everyone. Try this. What I have clearly understood, I will try to explain. You are comparing for the same planet, two different satellites. For the same planet, different heights. We know very clearly G at a height is G naught R square by R plus H whole square. I am sure everyone in this class have an idea on this. Now the question is, you want to compare at P and Q. So GP times R plus HP square is equal to GQ times R plus HQ square. Now the question is, they have given ZP by GQ as 36 by 25, which according to me is R plus HQ by R plus HP all square, which means R plus HQ by R plus HP is equal to 6 by 5, which means 5R plus 5HQ is 6R plus, don't forget they have given HP as R by 3, that they have given here. So therefore, 6 times R by 3 becomes 2R. So therefore, 5HQ becomes 8R minus 5R, 3R. So therefore, HQ becomes 3R by 5. This was given. Every year there will be one question from gravitation. More or less doable questions. Any doubt in this question at this point of time? Are we clear? Pakka? Right. Next. Second question. Don't see the solution. Actually, I have done the solution before you arrive here. Right. Just go through the question only. Just go through question only. Particle of mass m is under the influence of gravitational field of a body of mass capital M, much greater than small m, which is you can take m as a planet, small m as a satellite. Right. The particle is moving in a circular orbit of radius r0 with time period t0 around the mass, capital M. See, rotating one is small m, stationary one is a capital M. Now, at this point, that is the first part of the question. For the first part of the question, I know time period. T0 square is equal to 4 pi square r0 cube by gm. I know this. Right. Now enter to the second part. Then the particle is subjected to another central force, which is not necessary. Like, for example, you say previously due to gravitation it is rotating. Now you are given charges additionally. For example, just telling, electrostatic force is also there right now in the picture. Likewise, you assume something like that. Now, what is happening here? In this case, the particle is subjected to an additional central force corresponding to the potential energy, and a new potential energy is defined, m alpha by r cube, where alpha is a positive constant of suitable dimensions, r is the distance from the center of the orbit. If the particle moves in the same circular orbit of radius r0, in the combined gravitational potential due to m and VCR, both, new time period is a t1. Then, hold on. First, what is happening? As per the given data, we know this is the picture. This is what happening. Additionally, you already know F is minus dV by dr. F is minus dV by dr. Fc dash is minus 3m alpha by r power 4. Right, hold on. No issues. Now, minus sign indicates attractive. Already gravitation we know is attractive. So, both are acting inwards. Now, 3m alpha by r0 power 4 and Fc both are acting inwards. And that is, in fact, on the particle, it is mr0 4 pi square by t square. Right. Now, therefore, 3m alpha, no, I am taking both the equations right now. 3m alpha by r0 power 4 is 4 pi square. 4 pi square. What happened? Till this point, any doubt? Don't forget, a question itself, they have given some hint. You want this. I'll techukovalga first. So I made t0 square minus t1 square by t1 square t0 square. That is nothing but 3m alpha by r0 power 5 4 pi square small m. So this m and this m cancel. Right. What is left? Hold on. Meanwhile, one thing is there. In this, this I have substituted. I know t0 square. So I have substituted t0 square. Rest, everything is the same. So after our simple substitution based question, this is JEE Advanced, JEE Advanced 2024 latest. Now we have seen 2 years of advanced questions. Now see how direct these questions were. Which means if you are good at gravitation, 3 marks or 4 marks from this chapter is assured. Clear? Are we clear on this? Any student having doubt on this? Pakka? Sure? Right. Now we'll proceed for the next question. This was a difficult question at that time, 2022. A very difficult question actually at that time. So read the question carefully. Two spherical stars A and B having densities rho A and rho B respectively. A and B have the same mass, same radius, and their masses also given like this. Okay, hold on. Radius is the same. Wherever I have RA, RB, I will write it as R. Similarly, mass of B is 2 times the mass of A. Similarly, density of B is 2 times density of A. Why? Because volumes are same. Right. Due to an interaction process, star A loses some of its mass so that the radius is halved. Which means earlier it is a ball of radius R taking mass MA. Now it becomes a ball of mass MA by 8. Initially, mass of A is MA. Finally, mass of A is MA by 8. Now 7 MA by 8. Mass is deposited on what? Read the question carefully. The entire A is deposited as a thick spherical shell of on B with density rho A. VA and VB are the escape velocities from A and B after the interaction process. A ratio. Hold on. Now, please try to understand what is that. Now, the radius, just because of initially radius of B is R. Finally, radius of B will become, say, small r. Then 4 pi 3 pi r cube minus r cube. This much volume is filled with a material of density rho m. Yes or no? And this is equal to 7 by 8 times m, which means 4 pi 3 pi r cube minus capital R cube rho a is 7 by 8 times 4 pi 3 pi r cube a rho a, still rho a cancel. 4 pi by 3, 4 pi by 3 cancel. Finally, this is 8r cube minus 8 capital R cube is equal to 7r cube. So, which clearly indicates that wherever I have R cube by capital R cube, I can write it as 15 by 8. So, right? So, therefore, small r by capital R can be written as 15 power 1 by 3 by 2. Remember, this is a very important relation. Later, I am going to use. Right. Okay. Finally, all these things is okay. What do you want, basically? Now on A escape velocity. Let that be VA. We know VA is nothing but root 2 times G times mass MA by 8 and radius R by 2. Agreed? Boys and girls. Because you know the general formula is under root 2G mass by 8. Right. Now, therefore, VA is, you will get it as GMA by 2. Okay. One part is done. Now, the major part, what I am worried is the second part. 2R, right. Oh, okay. Fine. Right. Now, the second part is very crucial for me right now. Now, on the shell of radius R, potential energy is GMB by R minus G 7/8 MA by R. Yes or no? Are boys? On the surface of the present planet B. On the surface of the present planet B. Why? Earlier B, of course, is of radius R. Now it is covered with something else. Now its radius is smaller. So therefore, everything is on the surface of that shell. From the center, it is at a distance of smaller. From the shell also, it is at a distance of R from the surface, I mean, onto the surface. So this is the potential energy. And half uh, V square, VB square, escape velocity on B is 0. Therefore, escape velocity on B can be written as G, or MB can be written as 2MA by R plus 7/8 GMA by R. So now, yeah, this is going to be 23 by, sorry, here 16 plus 7. 23 by 8 GMA by R. Your problem is not at over. Hold on. Problem is not at over. Y into 2 into 2 into 2 means 1 minute into 2 means అరే ఇక్కడ 2 తీసుకెళ్ళి right into 2 means inside it is a 4 into 2 means inside it is a 4. So this will become 23 by 2 times GMA by R. Okay. That is not what we are working for. What you want is VB by VA. Now VB by VA. Now everything is clear. Now VB by VA is under root. Are all G terms common? VB by VA. This will become 23 by 2 MA by R divided by MA by capital R. MA cancel. Till this point, any doubt? MA by 2R. This 2 also gets a cancel. 23 times capital R by smaller. Now 23 times, just now I have given wherever I have whatever capital R 2 by rare, all that calculation, just let me just check once. Yakada, no, hold on, just VB square, right, 2 local kostundra root loki. No, 2, it is correct, 2. You will get 4 here. You will get 4 here. You will get 4 here. So therefore, a 2 is remained here. Now, smaller, capital R by smaller. Capital R by smaller, 2 by 15 power 1 by t. 2 cancel. This will become 23 by 15 power 1 by 3. Hold on, don't try to solve this. Go through the question. It's an IIT question. They won't torture you. They asked you what is 10N. So 10N is nothing but 23. N is equal to 2.3. This is a pakka relation. You know, still they have given range as 2.2 to 2.4. That is how IIT people are so merciful, actually. Right. Now, any doubt? See, what is majorly involved in this question? Calculation is the criteria. See, remember, when you are solving 11 out of 18 questions in IIT, each question you can minimum spend 5 minutes. In 5 minutes time, we have spent some questions till this point. I have solved 2 questions very fast. This question took some time for me, but I was very careful in each step. Because when you are solving, your friend won't give you a chorus, a backside. No, no, 2 cancel, 4 cancel, likewise. You should do this. So therefore, in that process, you must be very careful in the substitution process of every step. Right. Right. Third question. So to solve a third question, you require some concept called binary star system. Already, sir would have given you that information earlier. Otherwise, also, I will discuss once binary star system. That is the reason why I leave some spaces. Yes. Right. Here we will do. Binary star system. In some systems like this, you will have an arrangement where star 1 mass m1 and star 2 mass m2 were separated by a distance d. That is the only situation available in the space. And they move around their common center of mass. They move around their common center of mass due to gravitational force between them. Otherwise, if they are left like that, what will happen? They will move towards each other and collide. So now what is happening is, say this is at a distance r2. We know from the formula of center of mass, r2 can be given as m1 by m1 plus m2 times d. Are we clear? Very good. Now, m2 is experiencing a gravitational force. And this gravitational force is nothing but g times m1, m2 by d square. So, for the rotation, necessary centripetal force is supplied by the gravitational force. M2, R2, omega square. Omega is common for both, right? So, therefore, Gm1, M2 by d square is M2, M1 by M1 plus M2 times d omega square. Just do cancellation. Implies omega is nothing but g times m1 plus m2 by dq, or time period is nothing but 2 pi root dq by g times m1 plus m2. That's all you require. So they move with a common time period. This theory is required for you to solve the problem which I'm about to discuss from the previous IIT question. Right, we'll go to the question. Now I am speaking about this particular question. So see the question, first of all, everyone, try to see the question. The distance between two stars of masses 3 ms and 6 ms is 9r, where r is the mean distance between the center of the earth and the sun. ms is the mass of the sun. In the units of the mass of sun I have given, right? The two stars orbit around their common center of mass in circular orbit with time period nt. Hold on. Where t is the time period of Earth's revolution around the sun. Straight away, tell me what is t. 2 pi root r cube by g times mass of the sun. Do you know this? Now this is equation 1. What is the expression for the time period of binary star system? 2 pi root d cube. D cube by, hold on. Array, hold on here. Here, all that stuff is recorded here. Slow. So therefore, 2 pi times d cube. D cube here refers to 9r cube. Correct. By g times 9ms. This is equation 2. So therefore, t dash by t is nothing but t dash 9 cube by 1, 9 cube by 1 and 1 by 9. This is nothing but root 9 square. This is nothing but 9. So therefore, t dash is 90. The answer is 9. See, 2021. Just because of the fact that we feel it is very high at advanced, we will stop working on this at some later point. Stay confident. See how easy they were questions. Right. Next. A fourth question is what we need to work right now. Right. Yeah, please, everyone go through this question once. See, majority of the questions from IIT can be done just by proper reading part of that particular question. Also, you do mistake if you go overlook that particular area. Read very slowly. You see, consider a spherical gaseous cloud of mass density rho r in free space, where r is the radial distance from its center, and the gaseous cloud is made of particles of equal mass m moving in circular orbits about the common center with the same kinetic energy. That is an important term. The force acting on the particles is their mutual gravitational force. If rho r is a constant in time, that is also an important term for me. This is one important term. There is another important term, right? The particle number density, density per unit mass, otherwise. What I believe in this is, it is moving in a circular orbit. That you clarified me. And this is the particular mass, and I'm assuming the gravitational force is responsible for maintaining that in that particular orbit. And you know, this is the equation to write, assuming it is like a shell, and that shell encloses capital M mass till that point, right? And this supplies mv square by r. So G capital M small m by r is mv square, which can be written as 2 times kinetic energy. Now, what is variable in that is capital M and r. These are variable. Rest everything is constant. So capital M is 2 k r by g small, 2 k r by g small. Now dm is 2 k by gm tr. Are by this point, till this point, any doubt? Are what is dm? dm is, hold on. Yeah, someone was telling me, right? Rho into in a ఇంకోసారి చెప్పండి. కరెక్ట్. 4 pi r square dr. Good. So therefore, see, you know how to solve this, but just because of doing this fast, you are spoiling the concept. So therefore, whatever the mass in this only, in that thin portion, whatever the mass in this portion, this is the dr. So 4 pi r square dr rho is 2k dr by dm. Yeah, by the way, what best we can do is rho can be given as k by 2 pi r square g into m. Right. Right. Yeah. But that is not your answer. Unfortunately, if you go away, every denominator contains m square term. They are asking you rho by m to find rho by m, which is equal to k by 2 pi r square g m square. Right. Now tell me, just according to me, just this step is crucial. This is the crucial step. If you fail here, you will not reach the answer. Any student having doubt on this, please ask me. I told you number of times. When will we do mistake? We will do mistake while learning itself. When we compromise now, we will not do a problem like this at a later stage. Do not compromise. Learn properly. Question me wherever you have doubt. It is your fundamental right to do that. Do not compromise. Any doubt, any step, anywhere in this question, please ask. Are we clear? Why capital M is? Can I ask you another question to counter your question? What is capital M? Mass of cloud till that point. As the radius increases, increases. That is why M is variable. Now you didn't heard properly. That's what I uttered that by the moment when I'm starting this question. Yes or no? So no, I don't find that you are not serious in taking this. You didn't took that term as serious as something. Maybe coming steps there is some serious step. There we will miss. Right. Are we clear till this point? May I proceed for the next question? This is a very simple question actually. Matrix match. You can easily do this. Planet of mass M has two natural satellites, M1 and M2. Radii of their circular orbits are R1 and R2. And forget about the interreaction of two satellites with each other. Satellites will interact only with Earth only, that's all. Right, or planet in that case. V1, orbital speed, L1, angular momentum, K1, kinetic energy, T1, time period of revolution of satellite 1, similar terms 2. Then, very simple. Any information given to me? No, they have given only two informations. M1 by M2, planet's mass ratio, radius ratio 1/4. Do orbital velocity depends anything related to the mass of the orbiting object? No. Now we know orbital velocity formula is root 2 times g mass of Earth by radius. So therefore, V1 by V2 is root R2 by R1, which means root 4 by 1, which means 2 is to 1. So P matching Are you how? Twos are there. While we are learning, don't go like that. We are learning, don't go like that. Next. Next point. Next point, angular momentum. So, what do angular momentum stands for? MVR, which means under root G mass of earth m square r, numerator r square, denominator r. So finally L depends on m square and r term. So therefore L1 by L2 is under root m1 square by m2 square times r1 by r2, which is nothing but m1 square by m2 is 4:1, r1 by r2 is 1:4, 1:1. So therefore P2, P3, Q2. Yes or no? Arya, just please confirm. 1 minute. P is 3. Q gives right. So which option is matching for this? Option B. Correct. Our kinetic energy is velocity square. M1 square, M1 by M2, V1 by R. Simply, kinetic energy ratio is same as potential energy ratio. So simply you take R2 by R1 and M2 by M1 by M2. So R2 by R1 is 4:1, M1 by M2 is 2:1, and it is 8:1. So therefore R is 4. Time period T square proportional to R2. Use that for finding time period. Are you 2008? Every year you have a question. Now out of 5-6 questions, only one is difficult. That too lengthy. Right. Next question. Question number 6. Go through the question carefully. Everyone try to go through the question carefully. A rocket is launched normal to the surface of the earth, away from the sun, along the line joining the sun and the earth. Sun is 3 into 10 to the power of 5 times heavier than earth. Mass of sun is 3 into 10 to the power of 5 times the mass of earth, and it is distance of radius of the sun's orbit, earth's orbit is 2.5 into 10 to the power of 4 times the radius of the earth. Rest. Right. Hold on. For example, this is earth, and here is sun, and you want to escape like this. Common sense, don't throw velocity towards the sun. It won't escape. That is the reason why legibly they have given in the question. Now the question is, what is the total energy? Minus G, mass of earth small m by radius of earth, minus G, mass of sun small m by rs, plus half m V escape square is equal to 0. So therefore, V escape is under root under root 2 times G ME by RE plus 2 times GMS by RS. In this, I can rewrite this as 2 times GME by RE into 1 plus. Now mass of sun you will represent with 3 into 10 power 5 by there is a 2.5 into 10 power 4. Yaar, trust me, this is already this entire part, left hand side part under root will 11.2. You break it otherwise. 2 times GME by RE times root. This will becomes root 17 nearly. Root 17. Yes or no? Now the question is, this is already 11.2. Suppose if this is 16, 4. Now you check the answers. This won't match, this won't match, this won't match. Why should I do calculation? This is already available. If it is 4, I would have written nearly likewise. So that's all. Anything else you want to discuss on this? Okay, clear? Pakka? Sure? Actually, that is called third cosmic velocity. Next. 7th question, read carefully. A bullet is fired vertically upwards with a velocity v from the surface of a spherical planet. When it reaches its maximum height, its acceleration due to the planet's gravity. So, GH is G naught times 1 by 4. Right. Now, which is clearly, normally you will write this as G naught R square by R plus H whole square, which implies R plus H is equal to 2R and H is equal to R. Equation 1. But we know the formula, no? What? H is equal to V square by 2G minus V square by R, which implies V square is equal to 2RG minus V square. Remember, 2V square is V escape velocity square. Don't forget, root 2RG is V escape velocity. So therefore, you are projecting with a velocity 1 by root 2 times V escape. And they are asking me, V escape is root 2 times V, and what is that term? 2. So the answer is 2. What kind of questions we are doing literally? Now, can we make it or not? Right. Then you may ask me, when questions are of this level, why you are making us to do higher order problems? The objective of higher order problems is not to crack entrance examination. The objective of discussing higher order problem is to crack your thinking capability beyond the 12th level. Unless or until you don't do such problems, unless or until you score 100 plus runs, 150 plus runs in a Ranji match or a local league match, you can't score 50 plus in a international match. Trust me. Next. Yes, 8th question. Right. Do this. Already done. Right. I'll make it fast then. Yeah, 7 by, right. A very simple question, this one. No, this is how much distance? 3L. 3L. Hold on. 3L. Now let this be A, let this be B. Now you take the free body diagram of A. This should experience G capital M small m by 9L square and minus gm square by L square, and this contributes some A acceleration. Similarly, the other mass will experience two forces like this. G capital M small m by this time 4L square. 16L square plus gm square by L square. That contributes A acceleration. If both have same acceleration, there won't be tension. If they have different acceleration, for example, left side more acceleration, right side less acceleration, what happens? Tension starts. You don't want a tension condition here. That is possible only when both are moving with same acceleration. The rod neither elongated nor compressed. Right. Next. Now from this I can say G capital M small m by 9L square minus Gm square by L square is G capital M small m by 16L square plus Gm square by L square. By solving which you will get the condition as capital M 7m capital M by 288 becomes small m. They are asking what is this K? That answer is 7. Any doubt? Right. 2015, you see two questions were given from gravitation. Next. Earlier, I have started my very first class with this pressure formula. Any doubts? I have started my class with this formula only. This is the formula 2 by 3 pi g rho square, capital R square minus small r square. Right. You need the same formula here. Right. Now use this formula. Automatically, what they want? A spherical body of radius r consists of a fluid of constant energies in equilibrium under its own gravity. Then correct options are P at R is equal to ninth question. You see, what is that they were giving? Ninth question. Now you take R is equal to 3R by 4. And then what is going to happen? Just stay like this. Rho square, capital R square minus R square, 9 by 16. What is going to be 7R square by 16? R is equal to 2R by 3. Pressure is equal to 2 by 3 pi g rho square, 1 minus 4 by 9, 5 by 9 R square. Equation 1, equation 2. So therefore, P at R is equal to 3R by 4 divided by P at R is equal to 2R by 3 becomes obviously 9 into 7 by 16 into 5. 63 by 80. Just formula substitution. But at that time, formula should strike. You should not tell me a reason that I forgot the formula. Remember, I haven't given you formula. I have derived things. Type permits, derive then. What to do? Right. But these are very special formulas. You should remember. Next. 10th question. An easy question. Planet of mass, planet of radius. 1/10 the radius of the Earth has the same mass density as Earth. Right? Hold on. We have already done in the class. We have done this problem in the class. You wish me to show, I'll show you. Hold on. This is the question. We have done this, right? So therefore, for that question, you will get an answer of nearly 108 Newton. We got the same, I think, there. 108 Newton. Only thing is, proper integration is to be taken care. You will get 108 Newton as the answer. We have already done this.